Hi, I thought I would tape a video on how to graph exponential growth functions. So we worked on this last week some, and there was some steps involved. So first you have a function, and this function in particular is y is equal to 3 to the x power. So the first step that you take in this is that you use your calculator and you plug in the function y is equal to 3x, and you do that by pressing table and then typing in the function, and then you press enter, okay, and then it gives you a table here. So I'm going to create an xy table, and when x is -2, y is 1/9, and when x is -1, y is 1/3, x is 0, y is 1, and I continue it on also to some of the positive numbers, and when x is 1, y is 3, and x is 2, y is 9. So I take these values that I got from my table and I graph them on my graph. So I have -2 and 1/9, and -2, 1/3, -1 and 1/3, 0, 1, 1, 3, and then 2 all the way up to 9. So this is what my function is going to look like. And I have arrows on either side of my function, because it continues on and on and on to -infinity to the left and +infinity to the right. So now I want to know, so my x value over here is -infinity, and my y value is actually going to 0. I'm going to go ahead and put that at the end of my graph over here. Now up here at the top of the graph, and this right here is heading in the +infinity direction for x and the +infinity direction for y. And that might help you a little bit with your end behaviors. So the domain asks what x value do I have a graph for, and in this case it's all real numbers. Range, I have a graph, what y values do I have a graph for, and all y's greater than 0 I have a graph. Asymptote, here an asymptote is at y is equal to 0, because as you recall this is just +0, but it gets closer and closer and closer to the x-axis as the graph goes to the left. So that is your asymptote. Intercepts, I have the intercept from our graph and from our table. We have an intercept at 0, 1. In my end behavior, I'm asking what are my y value, or as my x values go, as x goes to -infinity, what is happening to f of x or y? And in this case it's going to 0. And as x goes to +infinity, f of x or y goes to +infinity. So that is my end behavior. In my intervals, what is my graph doing as I look at it from left to right? And it is increasing. So it is increasing from -infinity to +infinity. Now, the next graph that we did in class is the function y is equal to 1/4 times 6 to the x power. So I'm going to clear this, and I'm going to plug in, use my fraction, 1/4, and then I'm going to put in parentheses this 6, and I'll raise that 6 to the x power. So that is what your calculator should look like. And then I'm going to press enter, 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 okay, and it gives me my graph. So I'm going to go from, again, I'm going to go from -2 to +2. So I have xy, -2 is going to be 1/144, so it gets closer and closer to 0, 1/24, 0 and 1/4. Keep on going. Then I have a value of 1, and then I'm going to change that to 1.5, 3/2, and then at 2 it's going to 9. So next thing we do is we graph it. So at -2 I'm getting closer and closer and closer to 0. Not quite there, but closer and closer, and then at 1 I'm at 1.5, and at 2 it's going to be all the way up there. So I'm going to graph this. So that's what our graph would look like. Again, as my x value is going to -infinity, my y value is going to 0. And as x is going to +infinity, y is going to +infinity. Domain, I have a graph for all x values, so it's all real numbers. I have a graph for all y values greater than 0. And I have an asymptote where the graph gets closer and closer and closer to 0 at y is equal to 0. Intercepts, I'm going to intercept the y-axis at 0, 1/4. There is no x-axis that's intercept. End behavior, as x approaches negative infinity, f of x approaches 0, and as x approaches positive infinity, f of x approaches positive infinity. And again here, my graph is increasing as I'm moving from left to right, so from negative infinity to positive infinity. So you kind of see a pattern here. Well, then we got to the point here where we talk about the transformations and how graphs would look. So our parent graph here is y is equal to b to the x power. So there's some transformations going on. The negative in front of the b tells me that it's reflected. The a is either the stretch or the shrink factor. Shrink factor. The h is the shift either to the left or to the right, and it's opposite of what you think it is. K is going to be the shift up or down, and this is also the asymptote. So that's how I can find the asymptote. So looking at the graph of the function in example 3, I have an asymptote right off the bat. I can say y is equal to -2. And I can draw that on my graph. That means my graph is going to get closer and closer and closer to -2, but never cross over it. So I'm going to put my function in my calculator, and I do believe that I already have that function in there. Let's see. So I sure do. So I've already placed it in here, so I'm going to just get my table, and I'm going to have to scroll up because some reason it started at 60, and that's just based on the calculator, so you keep scrolling, keep scrolling, keep scrolling, keep scrolling, and this may happen to you sometimes, so I'm just going to give myself a -2 value. It's going to get closer and closer and closer to -2, so it's -1.98, and then at -1 it's going to be -1.93. At 0 it's going to be -1.78, and at 1 it is going to be -1.3 repeating, and at 2 it's going to be 0, and then if we want to give ourselves one more, at 3 it's going to be 4. And I've just gotten those from the table function on the calculator. So I'm going to graph it at this point. It gets closer and closer and closer to 2 on this edge, or -2 on this edge, and I have 1 and -1.3, 2 and 0, and then 3 and all the way up to 4. So my graph looks like this, and it has a shift. So we have domain, again, we have a graph for all x values. In range, we have a graph here, y is greater than -2. End behavior, as x approaches negative infinity, f of x is approaching -2, because I have negative infinity, -2 over here, positive infinity to positive infinity up here. And so as x approaches positive infinity, f of x approaches positive infinity. And then my intervals, again, it is increasing from left to right, from negative infinity to positive infinity. Example 4, the graph is set up where it's not going to work, so I can just do what I know how to do. So I know that my asymptote here is going to be y is equal to -3. I know that it's going to get closer and closer to -3 as I go here. But I do know that the graph is flipped. So the graph is going to be somewhere along this line, which is not even on the graph. So I'm not going to graph that. The next thing we talked about was decay. And you do decay the exact same way. But instead of having a whole number, instead of b being greater than 1, now 0 is going to be less than b, and b is going to be less than 1. So it's going to be a fraction in here. So let's look at our function and let's graph this. So I have 1/3 to the x power. And you just have to be really careful when you plug these into your calculator. So in this case, again, I'm going to have a table, and -2 is 9, -1 is 3, 0 is 1, and then 1 is 1/3, and 2 is 1/9, so it kind of flips it around. So -2, I'm going to be all the way up here. -1, I'm going to be at +3. 0, I'm going to be at 1, and then as it as x goes to +infinity, f of x is going to go closer and closer and closer to 0. So the graph looks a little bit different than it did in our example 1. This is what our example 1 looks like, and so the graph is increasing as it goes from left to right. Here, my interval, it's going to be decreasing, and that's where the decay comes in. Decreasing from -infinity to +infinity. And if I'm doing my end behaviors, x is going to -infinity and y is going to +infinity. X is going to +infinity and y is going to 0 in this case. So domain, again, I have a graph for all x values. Range is y is greater than 0. Asymptote, y is equal to 0. Intercepts is going to be at 0, 1. End behavior, as x approaches -infinity, y approaches +infinity, and as x approaches +infinity, y is going to approach 0. So that gives you a little idea. Now, the same thing happens here. So negative means it's going to be something like this, my graph. It's going to be flipped over. It's a decay, therefore it's going to go down. So let's see if that graph is anywhere close to being right. So let's plug it into our table function. So I have -2, and then and then to the 3/4 to the x power. And then -2 is going to be -3.6. -1 is going to be -2.7. 0 is -2. And then 1 is going to be -1.5. 2 is going to be -1.25. And then it keeps getting closer and closer and closer to 0, and you can look at that on your table function. So, I'm right. It's getting closer and closer and closer to 0. Maybe it's shifted down just a tad, but your graph is going to look something like this. So domain, again, all real numbers. My y values this time are y is less than 0. Asymptote, y is equal to 0. Intercepts, I can get that from my graph, 0 and -2. End behavior, as x approaches -infinity, y is approaching -infinity. And as x approaches +infinity, y is approaching 0. So you can write that in, and then it is increasing from -infinity to +infinity, because as I read the graph, it's going up. So that gives you a little bit of idea about growth and decay functions.